Okay, so we have 15 questions on our upcoming test. So this test is little bit longer than your second test. It's going to be 15 multiple choice questions. But when I was creating the review, I did not create it as a multiple choice test so that we don't try to get the answers from the answer choices. We actually work through the problems and we understand how to work for each problem. So your actual test on November 4th is going to be 15 multiple choice questions. So the first question, and when I was creating this review that I just passed you, I kept the question order the same as the test. So if the first question on the review says, determine the end behavior of the graph of this function, that's what your first question on the test is going to say. Okay, so even the order will be the same, just the numbers will be different. So let's practice this question. So we learned this long time ago. This is lesson 3.2, end behavior. Okay, for end behavior, how many rules do we have? How many rules do we have? There are 4 rules that we have to know for end behavior, right? Let's just put the rules here for end behavior of the polynomial functions. We have 4 rules. And how do we develop these 4 rules? Does anybody remember these 4 rules? What do they depend on? We check 2 things. What are these 2 things that we have to check? End behavior means something like up on the right, down on the left. So when we graph these polynomial functions, is the graph on the left going to be up or down? Or the graph on the right is going to be up or down? So for end behavior, so this is lesson 3.2, we first have to check the degree of the polynomial. So the first thing we will have to check is the degree of the polynomial. When we say the degree of the polynomial, what are we interested in? What do we check? We check if it is. We check if the degree is. We check if the degree is even or odd number, right? So we have to check if the degree is an even number or an odd number. That's one thing we have to check. And then the second thing we have to check is what? If it's greater than 0. The leading coefficient, right? The leading coefficient of the polynomial, leading coefficient. These are the only 2 things we have to check. And then leading coefficient can be what? Positive or negative. So depending on these 2 things, we have 4 different rules. So let's just remember the rules again before we start our question 1 from the test. So this is what we're going to check. So if the degree is even, which means when you have a polynomial function, if the highest exponent is an even number, it can be rising on the left, rising on the right, right? This is one of the options for the end behavior. They sometimes call it as rises on the left, rises on the right, or the way the test is going to ask you is, we will say up, left, up, right. This is how the answer keys are created for the test, okay? This is option 1. Or for the even, the second choice is it can be down and down. So it can be down, left, down, right. However, now we have to decide. So we know that for sure, in order to get one of these cases, case 1 and case 2, in order to get these case 1 or case 2, we know that it must have an even degree, but for up, up, leading coefficient must be what? For up, up, it has to be a positive number. If it's a positive number, it will be an up, up. If the leading coefficient is a negative number, it will be what? Down, down, right? So these are the 2 things that we have to know. Whenever the polynomial has an even degree, so if the greatest power is an even number, the graph is going to be up on the left, it's going to be up on the right. Similarly, It's going to be down on the left, down on the right if the leading coefficient is negative. And these two things will only apply if we have an even degree polynomial, right? So I'm going to open more room here. So we're going to now write, if the degree is the other one, if it is not an even number, I am just going to grab some eraser to erase this middle a little bit. Okay. So if the degree is not an even number, but if it is an odd number, then we have two choices again. We might start low and high, or we can start high and low, depending on the leading coefficient. So if it is down on the left, up on the right, down on the left, up on the right, this is only possible if the leading coefficient is what? If the leading coefficient is positive. I try to put the positive ones in together in one line so it makes sense. It's gonna be up on the left, down on the right, if the leading coefficient is negative. So there are two questions about this on the test. If you don't memorize these four rules, you're gonna miss both of these two questions. So please, before you show up for the test, make sure that, guys, you actually memorize when do we get up or down. This is the only possible cases when the degree is an even number. When the degree is an odd number, if the leading coefficient is positive, we have down on the left, up on the right. If the leading coefficient is negative, we're gonna have up on the left and right on the down on the right. So you have to memorize these four rules because there are a total of 2 questions on the test just for this skill, okay?
The example of leading coefficient degree.
Okay, so let's just, then before we take this actual test question, I'm just gonna move this forward further down. Okay, so if you wanna do a couple examples before we start the questions. Okay. Let's put a function, and then let's say it starts with a 5, x to the 7th minus 6 third plus x minus 1. I really don't care all the terms. All I care is its degree and its leading coefficient. So when we look at the example I just created, let's look at the degree for this f function. What is the degree here? 7. Degree means the highest exponent, right? I don't even care if it is 7 or 5 or it's a different number. What I care is degree is odd number. That's all I care because the rules are about degree being odd or even. Now, the leading coefficient for this function is, what is the number for the leading coefficient here? It's a positive 5. So it's a positive number 5. Therefore, I have to check the rules for odd degree and leading coefficient positive, which I put right here. Degree is odd and leading coefficient is positive. That means when we graph this function, it's going to start low and it's going to end in high. Or if I talk in the way that test is created, I'm going to say it's going to be down on the left, up on the right. This is how we answer these questions on the test. And we have 2 questions. Yes, Mom?
Only for the, we have the first one, only the highest one.
Yes. The highest exponent is called the degree, and the number in front of the highest exponent is called the leading coefficient, right? Okay.
So the degree can be 3 if that's the highest one.
Yes. Okay, finally, let's look at the first question. The test is waiting for us. So this is what the first question on the test is going to look like. It says, determine the end behavior of this function. The function is, its name is n of x. It's negative 3, parentheses, x plus 3, 3x minus 2 to the 3rd power, x plus 5. What do you notice about this question and the example I gave you on the previous page? What is the difference?
leading coefficient is negative.
That's correct. But this question is not in the standard form, right? This is the factored form. And I cannot say the answer to them before I do an extra work. All right. All eyes are on the board, please. Look. First, we have to find the proper degree for this function. In order to find the proper degree for this function, I'm not going to multiply all this and find the actual function, okay? I just need this -3. I just need this -3. Look, from the first parentheses, I don't need the x plus 3. I just need the x because I'm going to find the degree. Again, for this 3x minus 2 to the third power, I don't need the whole thing. I'm just going to need the 3x to the third power. And then again, the last one, I just need the x instead of x plus 5. Because I want to find the real degree and I want to find the leading coefficient. Now, we have to do the extra work. So -3 is here, x is here. So we're going to raise 3x to the third power. When we are raising 3x to the third power, 3 to the third power is at 27. X to the third power is just x cubed and an x. Now, I'm finally ready to find the degree and the leading coefficient. We're going to multiply -3 by 27, which gives me a -81. Now, please stay connected with me. In order to find the degree, we're going to have to multiply x by x to the third and by x. The rule is when we are multiplying the exponents, we must add the powers. So I have a power of 1 here, 3 more here, which makes a 4, 1 more here, 5. So that means this n of x is a polynomial, which has a degree of 5. So its degree is 5, which means it's an odd number. And its leading coefficient is -81, which is a negative number. So I'm going to look for the rule where the degree is odd and the leading coefficient is negative. Because I memorized the rules for all these 4 cases, whenever the degree is an odd number and the leading coefficient is negative, graph always starts high and ends in low. So when I see a question like this, I will answer it's up on the left and it is low or down on the right. This will be the answer I will pick on the test for a question like this. And this is how we are going to do number 1 on the test. I'm going to wait a little bit until you guys copy the work, and then you can ask your questions if there's any. Okay? Anybody still copying?
Yes.
Okay. If you need to go back to your notes for this question, this is a lesson. We learned this topic in lesson 3.2. If you want to watch some videos on Alex or on YouTube, this is lesson 3.2 and behavior of the polynomial functions. Okay. There are 15 questions on the test. I keep repeating, but it's not scary once you study all these 15 questions, and you guys have a whole week to study. If you just make time to study 30 minutes every day, I think you should be fine. But consistency is the key. You should really study every single day to remember the material. Okay, now I want to copy the second question from the review. So that means this is what you're going to see on the test as a second question. We're going to study this one now. Okay. So, given f of x is equal to 3x cubed plus 25x squared minus 23x minus 45, find all zeros of this function, given that -1 is a zero. If s is equal to the sum of the three zeros, then what is s? So this, I wanted to keep the style of the question like this, even though it's not a homework question, because this is how HCC creates the final exam. HCC on the final exam, they're going to give you this style all the time, so I wanted you to get used to it. So we have a polynomial function is given, and they have a clue for us to use. If -1 is 0, what am I supposed to do with this fact? If -1 is a 0 for this function, what am I supposed to do with this fact? If you plug it in, it doesn't help us.
Right, x plus 3, I mean, x plus 1.
That's a good point. X plus 1 is a factor, but that's not going to also help me to find the other two zeros. If this is a third degree function, we need to find three zeros. One of them is not a puzzle. They already gave me. One of them is -1. So we have to solve the other pieces of the puzzle. We need to find two more zeros.
So we take the last one, the -45, and we do the factors, and take the first one, and then the factors of 3.
Okay. What's your opinion, Valerie? Correct. That's the answer I was expecting here. If -1 is a 0, we're going to use synthetic division to divide this polynomial by -1 because we're going to reduce the degree from 3 to 2. So we're going to, first step will be performing a synthetic division. So let's remember how we do the synthetic division. I have 3x cubed. How many x squares we have here? 25x squares. How many x's? -23. And what's the last number? -45. I have 4 numbers to use for my synthetic division. And what number goes here? -1, because that's what they gave me to use. Remember the rules for synthetic division. Always first number, we need to copy it down. So 3 just comes down here. 3 times -1 is -3. Add them up, 22. 22 times -1 is -22. Add them up, -45. -45 times -1 is +45. Add them up, a 0. What does a 0 at the end mean? It's the remainder. If it is a 0, is this a good thing or a bad thing here? It is a good thing because if a number is a 0 of the function, it has to give you a 0, right? It has to divide evenly, and you must, even on the test, if you're getting a number different than 0, you are on the wrong path. You're doing something wrong, right? You have to get a 0. Okay, so we know that this was a 0. Sorry about this. This was a 0. Now we're going to have something called depressed polynomial, right? So with these 3 numbers, we're going to generate a different function, g of x. And then g of x is going to be 3 what? 3?
X squared.
Good job. We always start 1 degree lower. Plus what number? 22x. And what's the last part? -45. So this is the second degree function. It's a quadratic function now that everybody in this class knows how to handle quadratic functions because this is lesson 1.4. We learned the quadratic formula. We learned the factoring. Now, if I were you, I will just try to factor this function to see if I can just find the zeros by using factoring. But if it is too hard for you because there's a number here, you're always very welcome to use quadratic formula, okay? But let me show you one more time how I can factor this problem. It's 3x squared, so I will break it down as 3x and x. For 45, I can use 3 times 15, I believe, 3 times 15. And 15 and 9 is not going to give me 22. So what about 5 times 9? I think I can use 5 times 9, 27 and 5. Yes, that's going to be a 2. So 5 times 9 is 25. 5 times 9 is 45. But one of them has to be negative, one of them has to be positive. So I'm gonna make this a positive number, make this a negative number. So when I multiply these two numbers, it's a negative 45. I still don't know if I break them down correctly. So last step, I do the butterfly method. So I multiply 3x and positive 9, which gives me a positive 27x. Then I multiply these two, which gives me a negative 5x. And when I combine them, that's a positive 22x right in the middle. So that means I'm on the right path on factoring. I do this quick and easy because again, I have done pages and pages of factoring problems. So when I do the factoring practice with this type of questions, I am able to recognize the numbers in my head. This means this g of x will be factored as 3x minus 5 and x plus 9. These are the factors of g of x. So last step will be setting each of these factors to a 0 and so for x. So 3x minus 5 will be set to a 0. And then we're just going to solve for x. And this will be the x here. And then I will take the x plus 9, set it to a 0. And x will be equal to a negative 9. So this question is also on the final exam. So it's very important that you understand all the steps I'm doing here. This question has 3 zeros. So first 0, second 0, and third 0. So we will have 3 zeros for this problem. Now, first 0 is given in the problem and we used it to reduce the degree for the polynomial. So negative 1 was given. So I just copied the first 0 as the given number. The second 0 is 5 over 3. I found it by factoring. And the third 0 is negative 9, and I found it by factoring. Remember, the hard part about this question on the test is they want us to add these three numbers, because if S is the sum of these 3 zeros, what is S? So the last step will be S will be the sum of these 3 numbers. So we need to add the negative 1 with negative 9, and I need to add them with the third 0, which is 5 over 3. So if I add these whole numbers first, that's a negative 10. And I need to add this with the fractional 0, which is 5 over 3. This is where maybe some of you struggle, but final exam will require you to add the whole numbers with fractions. So you have to understand them to pass this course. So I'm going to get them in common denominators. So I will multiply the first one by 3. So it will become negative 30 out of a 3, because when I divide them, it still gives me a negative 10. And I'm going to add this with 5 over 3. Once the denominators are matching, I can combine the top numbers and keep the same denominator. So this is the S value they want in this problem. This is how you're going to solve. So you're going to say answer is, answer will be here, negative 25 over 3. When you add these 3 solutions, and this is how you do this question. First, I added the negative 1 with negative 9. So I just changed the orders. Negative 1 is the first 0, negative 9 is the third 0.
So what?
How did minus 1?
Where did minus 1 come from? Remember, it's a given 0 in the problem. Negative 1 is given in the problem. We found the other 2, so we just had to add all these 3 numbers. Yes, Alan.
You said worst case scenario, we can't figure that out. We can do that.
Yes. So if you don't know how to factor this, A is 3, B is 22, C is negative 45. You can do the quadratic formula. You're going to find the same 2 answers with me, but it's just going to take longer. Yes, China?
So why do you need 27x minus 5x is 22x? Why did we need that?
That was for me to check if my factoring is right. So I could have done this part in my head to make sure that my factoring is done, but I was just showing people my thinking procedure while I was factoring this. Because when I do the butterfly method, I have to get this number in the middle, 22x. Otherwise, my factoring is not correct. Okay, this is number 2 on the test. Not only for this upcoming test, but you have to understand this problem type for also final exam. This question will show up again in December on the final exam. This is their favorite question style. They will definitely ask you this in December. Okay?
This is 3.4 left.
This is lesson 3.4. Yes. I can put the lesson number here as this is lesson 3.4. Okay. So, Alan, you have a question here?
If you do the quadratic formula, you get 2 is 0.
Okay, I can actually now do this part with quadratic formula to remind you quadratic formula. So let's just copy g of x. I think since I don't want to make a mistake, I want to just cut this portion again and paste it on the next page. So on page 3, if you didn't know how to factor, but you wanted to handle it with quadratic formula, where did it go? Over here. Okay. So let's remember. Ellen, you want to help me? What's the first thing you have to find out here? A is,
3,
B is,
26,
C is
negative 45.
-45. And you're right about delta. And what's the formula for delta?
Square
B squared minus
minus
4AC. So here, what number is B? So we're going to have to square the 22. And then 4 times A is 3, C is -45. It's not going to be a super easy test, but it is still doable as long as you know multiplication, right? Yeah, but it might be as big as these. I don't know. So that's a 44, and that's a 44 too. So when I add them up, it's 484. So when we square 22, we get 484. Now, negative times negative is positive. 4 times 3 is 12. So I just need to multiply 45 by 12, which will be a 90 and a 45. So when I add them up, it's a 540. When I add these two numbers now, that's such a big number to take square root, but if sometimes for me, learning factoring is easier, but anyway, it's 1024, 1024. I like this number because it's a famous number in math, okay? So we got the delta. Now, first, we have two solutions, which we are going to use negative b plus and minus square root of delta all over 2a. We're going to use this formula to find the zeros. So I'm going to have 2 zeros. If b is 22, I'm going to write negative 22. And then I need square root of 1024 over 2 times a is 3. Okay. Square root of 1024. I believe this is 2 to the, let's see, 6th power is 64, 7th power is 128, 8th power is 256, 9, yeah, this is 2 to the 10th power. This is 2 to the 10th power. So therefore, when I take its square root will be 2 to the 5th power. And 2 to the 5th power means 32. You see how math is very powerful? If you are good at numbers, if you get along well with numbers, there's nothing you can answer. You can
Right. The factoring was easy, quadratic.
But anyway, square root of this number is at 32. So first zero will be negative 22 plus 32 over 6, which is a 10 out of 6. And 10 out of 6 is the same thing as 5 over 3. The second zero will be calculated as negative 22 minus 32 over 6. That's a negative 54 divided by 6. Negative 54 divided by 6 is negative 9. As you see, we got the exact same 2 zeros as I got with factoring. But if you want to study engineering, computer science, anything math related, there is no way. You have to learn factoring. I have been telling you since the day one of this class. I have been telling you, you cannot survive any of your math courses if you do not understand factoring properly. Therefore, my advice is always make extra time, study factoring properly, make sure that you know how to factor anything. Yes. Remember, if there was no number here in front of the x squared, you don't have to do all this. So, you guys, let me, is there a way I can just cut rid of this? No, I cannot.
So
Okay.
there's no number, so quadratic form, it'll be.
No, if there is no number, something, if the question looks like this, you don't need the butterfly method because there is no number in front of x squared. All you look at is the last number. You say, okay, this is 3 times 4. 3 times 4 is 12. And they both have to be positive numbers. So when I add them up, it's a 7. So the factors are x plus 3 and x plus 4. This is the easy factoring. But what makes it hard on the other question is having a 3 here, I can't use that easy method anymore. So I have to use that breakdown method, butterfly method. You understand? Okay. I think we spent enough time on question 2. Let's move to question 3 right now. Okay, let's see, how can I do this here? In this question, if I select all this, does it erase? This is one thing I don't like about this PDF editor. Is this the drawing shapes? Okay. Yes, go, 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 go away, go away, go away. Why are you not going away quickly? Okay, now if we go back to our test review paper, the third question is a lot easier than number 2. And again, I have 2 questions about this objective, which is finding the vertical asymptote and horizontal asymptote of a rational function. So you're going to have 2 questions on the test total, which is going to ask you to find the vertical asymptote and horizontal asymptote of a rational function. I have f of x is equal to x squared minus 16 over x squared minus 25. The question says, find the vertical asymptote and horizontal asymptote for this function. So for vertical asymptote, what part of the function do I check? Denominator, good job. Vertical asymptote is only about denominator. And what's the denominator of this function?
X squared.
X squared. X squared minus 25. This is the denominator. What am I going to do with this denominator?
Equals 0.
Equals to 0. Okay, this is the denominator. We're going to set this equal to 0. Because we have a quadratic function, what am I supposed to do with this? We're going to factor this. What's one factor? X plus 5. And the other factor is x minus 5. And we're going to set each of these factors to 0. When we set this one to 0, this gives me x equals what? X equals -5 is one of the vertical asymptotes we need for this question. And then when I set this one to a 0, this gives me x equals what? 5. X equals 5 is the second vertical asymptote. So this question has 2 vertical asymptotes. 2 vertical asymptotes. VA. And one of the vertical asymptote is x equals -5. The other vertical asymptote is x equals 5. If you remember my last week class, we said asymptotes are always equations. So you have to give them as equation, not like you can't say 5 or you cannot say -5. You have to tell them that vertical asymptote is x equals 5. X equals -5. Okay, that takes care of the vertical asymptote part. The other thing I have to locate is the horizontal asymptote. How am I going to find the horizontal asymptote here? Anybody remembers the rules for horizontal asymptote? Good job. Yes,
then that means they have to fraction of the median.
that's correct. So this is the information I was looking to hear. So the degree at the top is 2, degree at the bottom is 2. Since they have the same degree, so horizontal asymptotes, we have to check the degree for the top and the degree at the bottom. For horizontal asymptote, we have to check both the top and the bottom. So here we have a degree of 2 at the top and degree of the 2 at the bottom. So they have the equal degree. So horizontal asymptotes, they always start with y. Since we have 1x squared at the top and we have 1x squared at the bottom, so the horizontal asymptote for this question will be y equals 1. So this question has only one horizontal asymptote, which is y equals 1. This is how we're going to find the answer to this question on the test. If they give me a function like this, yes, China.
Is it because it's 2 over 2 and that equals 1?
Say it again one more time. No, not the powers, because we have 1x squared and we have 1x squared. If this was a 3 here and a 2 here, the answer will be 3 over 2.
Oh,
Okay, I think I'm gonna just create one. Mohan, you have a question too?
If there is, we have to do for the leading coefficient for the.
Yes.
There is 2x squared and 5x squared, and so we verify.
Yes. Okay. Let's just create a very similar question. So we're gonna keep everything the same. We're just gonna change the function to understand what's happening. Okay. All right, are you guys ready? So let's say, I'm just gonna change the function. So I'm not gonna write the whole thing, but let's say f of x is actually 3x cubed minus 1, and then 5x cubed minus 1. Let's say this is the function. And again, we're looking for the vertical asymptote, and we are looking for the horizontal asymptote. All right? Let's start with the vertical asymptote. For vertical asymptote, which part of the function do I check?
the denominator.
The denominator. 5x cubed minus 1 is the denominator. What do I do with the denominator? We're going to have to set this to a 0. Okay? Now we're going to have to solve this for x. So if I add 1 to both sides, 5x cubed is 1. Divide each side by 5x cubed is 1 over 5. Then I know I didn't pick a nice number here because x is cube root of 1 over 5. Don't worry about how I got this answer, but just know that we have one vertical asymptote here, just one vertical asymptote. It's cube root of 1 over 5. There's only one vertical asymptote. This is the only vertical asymptote. Now, for horizontal asymptotes, we have to check the degree at the top and degree at the bottom. Do they have the same degree, or the bottom is stronger or the top is stronger? What is the answer here? Same degree. Horizontal asymptote, they always start with what? Y. Okay. How many x cubes we have at the top? 3. How many x cubes do we have at the bottom? 5. So there's only one horizontal asymptote here, which is y equals 3 over 5. This is how we're going to answer these questions. Y equals 3 over 5.
If there is 3x and 5x more than 5.
Okay, I think you have to tell me the function and I need to write down to answer. Say, what is your top? 3x cubed minus 1.
And 5x4.
Okay, for the horizontal asymptote in this case, because they have no longer the same degree, we go back to the other rule, bottom has more degree than the top, and whenever bottom has more degree than the top, you have only always this horizontal asymptote, which is y equals 0. We don't do the ratio, we don't do anything else anymore. The horizontal asymptote will be always y equals to 0.
Like this question, we not
I cannot tell you, there are 3 rules we covered in class. And then I also create this as an Alex review, so you can always regenerate the problems to check all the options. Okay, so go back to the test review. I cannot believe that we only covered 3 questions in 45 minutes. All right, we're on number 4 now. So I'm glad that I actually dedicated 2 sessions for this review, because for you, it is important that you are getting a good grade on this upcoming test is because final exam is not simple. It's not simple. So you want to accumulate as many points as possible for my test, since I am just making you focus on 15 questions at a time. It's doable. But when you have the final exam, it's 33 questions that you have to master in one sitting. So it's from the beginning of the course to the end of the course. Therefore, usually final exam averages are not very high for college algebra. I am really trying to make sure that you guys earn as high points as possible for my tests before the final exam comes, so that you can make yourself pass this college algebra in a way that you don't have to repeat it forever. All right, number 4 on the test. Find the zeros of this function and state the multiplicities. I like this question way too much. Why do you think I like this question way too much? Because this is different than question 2. If you look at question 2, where we had to also find the zeros, right? For question 2, we had to find the zeros. Look at the given function in question 2, and -1 was given as a 0. What did we have to do? We had to divide it, we had to factor, find the zeros, right? But when we come to question 4, what is super nice about question 4? It's already factored, no division required, nothing, it's already factored, right? How many factors are there? How many factors are there here? 3. X plus 4 is a factor, right? X plus 2 is a factor, and x to the 4th power is the 3rd factor. So let's start from the backwards. X plus 4 is a factor. If this is a factor, what is the 0? Yes, therefore, -4 is a 0, because all we have to do is set this to a 0, right? -4 is the first 0 we are looking for. And what is the multiplicity for -4? Good job. Multiplicity is 2. That takes care of my last factor. X plus 4 gives me a -4 as a 0, and its multiplicity is 2. Now I'm waiting. You guys are answering the middle one. For the middle one, what's the factor? X plus 2 is a factor. Therefore what? Good job. Therefore, -2 is the other 0 we are looking for. And then what's the multiplicity for -4?
3.
Good job. Multiplicity is 3. Perfect. And now one last thing. Again, can you guys look at the board quickly? This -3 is no important for us. This -3 does not affect any of our answers, okay? So the last factor is x. X is a factor. If you think, you can think this like an x minus 0, right? It's the same thing. X is a factor. Therefore, what is a 0? 0 is a 0. And what's the multiplicity?
4.
Good job. Multiplicity for 0 is 4. And this question style is, again, definitely on the final exam. You have to understand this. Mohan, what's your question, sir?
It's the power.
Multiplicity is the power of the factors, correct? Yes, yes.
Oh, okay.
Multiplicity is the powers of these factors, exponents.
And it's
So -4 is a 0, -2 is a 0, and 0 is a 0.
Now, the next one is what I'm saying. We do the 3 final factors.
You mean the next one means the next question on this one?
Yes.
Yeah, okay.
why we like to do it?
Okay, let me look, stay connected with me, Mohan. I want to just make a little change on the problem. Look, just stay connected. The question starts with a -3, which is no important for us, right? Now, do you see this x to the 4th, right? I have a power to write it as an x minus 0 to the 4th power. Therefore, 0 is a 0, and its multiplicity is 4. You got it? But when it is 0, they just don't write us because they want us to be smart enough to figure this out on our own. Okay? All right, that's question 4. Anybody have any questions with question 4? All right. So I'm going to move you guys now to question 5. Again, on the test, this is the order you're going to see these questions. Of course, order doesn't make any change, but you can practice them also using the Alex assignment. Since I shared this review with you as an Alex assignment, it's not for a grade, but you can regenerate these problems and practice them as many times as you like. Question 5 states, if you have this polynomial function, how do we list all the possible rational zeros? So we're not finding the real zeros. We're just giving them the possibilities, right? Does anybody remember how to do this? Is that how we do it? Yeah, the last number is 3. What do I do with the 3? Yes, I need to find the factors of 3. I can divide the 3 by 1, so it's plus and minus 1. Good job. I can also divide the 3 by 3. So there are 2 factors of 3, 1 and 3. That's done. I have to do the same thing for one more number. What's the other number I have to do this?
10.
10, leading coefficient. I can divide the 10 by 1. I can divide the 10 by 2. I can divide the 10 by 5. And I can divide the 10 by what? 10. Now we are ready to find the list of the possibilities, right? So we're going to stick with 1 first. 1 divided by 1. What's 1 divided by 1? 1. Now 1 divided by 2. What's 1 divided by 2? Good job, 1 over 2. Now we have 1 divided by 5. What's 1 divided by 5? Good job, 1 over 5. Last 1 divided by 10. What is 1 divided by 10? Good job, 1 over 10. These are the possibilities because of 1. We will keep doing this for 3. Next number in line is 3. Let's change color here. So we're gonna now divide 3 by 1. What is 3 divided by 1? 3. 3 divided by 2 is 3 over 2. 3 divided by 5 is 3 over 5. And 3 divided by 10 is 3 over 10. So this is the answer they expect us to give on the test. Plus and minus 1, plus and minus 1/2, plus and minus 1/5, plus and minus 1 over 10, plus and minus 3, plus and minus 3 over 2, plus and minus 3 over 5, plus and minus 3 over 10. When you are doing this question on the test, if you get the same number twice, you are not going to repeat it. Remember your homework question. I put these questions on the homework. It was saying on the homework that if something gets repeated, do not write it twice, right? You just write them once. We have 2 questions like this on the test. This is lesson 3.4 again. This is lesson 3.4 again. If you want to look for your Alex assignments regarding this number 4 is, this is lesson 3.2.
The last number always goes from top, right?
Yes, always from top to bottom. Okay, that's question 5, listing possible zeros. You have 2 questions like this on the test. So if you understand one, top to bottom means the last number first and then the leading coefficient. And yes, always from top to bottom.
And 5 is less than 3.
This is, you're right, 3.4. Okay? All right. Let's move to the next one on the review. I think it's going to be easier now because it doesn't have a lot of complications. It's just a division problem. Question 6 on the test is just a division problem. So select. We're going to do a synthetic division to find the answer. For synthetic division, before we jump to the problem and before we act the division process, what's the first thing we always have to make sure? It's in order, right? You have to make sure that before you do anything, fifth power, fourth power, third power, second power, first power, and zero power. Is this problem in order? Yes, so you don't have to move things around, right? So let's start our synthetic division. What's the first number I need? 2x to the fifth. How many x to the fourth? 9. Next, positive 43. Next, negative 25. Next, last number is 45. Then we make this division sign. Yes, good job. We always have to put the opposite of this sign because it's coming with an x, right? Whenever it's coming with an x, when it is as a factor, you have to always put the opposite of this number.
You forgot the 2 and
Oh, I don't see properly. See, I need glasses. 51, 45. 2, 9, 43, negative 252, negative 1. Thank you so much. Okay. So once we copy the questions, the numbers correctly. So don't make the mistake I did on the test. If you copy one number wrong, you will just get the wrong answer, right? What happens to the first number?
It comes down.
Yeah, we just copy it downstairs too. What happens to 2 now? 2 times 3 is 6. What do we do with these two numbers?
We
Add them. 9 plus 6 is 15. Now, 15 times 3 is
41.
45. Add them up. 88. 88 times 3. 3 times 8 is 24. 2 is the carry. 3 times 8 is 24. 2 is the carry. Okay. When I add them up now, I get positive 12. When I add them up, I get a positive 12. Now what's going to happen to the positive 12 and 3? Yes, 12 times 3 is 36. Now when we add the negative 51 and 36, what do I get? Negative 15. Yeah. Finally, negative 15 times 3. Negative 45. When we add these two last numbers at the end, what do I get? This last number at the end is always what? My remainder. When the remainder is 0, we don't have to put it. So the answer we expect in this question is, if the question started with a 5th degree, my answer will start with a 4th degree. So can you guys help me to construct my answer? 2x to the 4th plus 15x to the 3rd plus 88x squared plus 12x minus 15 plus my 0. When it is 0, you don't have to write it, but on the test there's a remainder, so I want to go over this part with you. When there's a remainder, you put the remainder plus out of x minus 3. That's how you are going to put the answer, because on the test, you're going to get a division where you have a remainder. So once you have a remainder, you're going to put it as plus your remainder divided by your divisor.
Like this, we have to write.
If it is a 0, you don't have to, but on the test, this is a number different than 0, so I wanted to just go over so you do remember how to
Only
put
if there is number different than 0, we have to do.
So there is 0, we don't.
If it's a 0, this part disappears normally. But I just wanted to go over on the test, it's not a 0, so you have to put something here on the test, okay?
It's all the same, right? Only the.
Numbers are different. Yes,
It's only the first one that loses the power. Right?
yes. No, everybody, look.
Oh, okay.
So everybody, 5th become 4th, 4th become 3rd, 3rd becomes 2nd, 2nd becomes 1st, x becomes the number. We're just getting a 1 degree lower. Any questions about synthetic division? Again, on the test, we have 2 problems about synthetic division. So once you learn one of them, you're guaranteeing 2 questions.
I'm just making sure if it is 0, you want us to write it like that.
On the test, it's not a 0, so you will have to write something like this. Okay. But if this was an Alex question, you wouldn't need this part. You just put this answer all the way. 15 is the last thing you put. Okay. All right, let's go to the next question, number 7. Okay, look at number 7. That's a concept we already revealed. So Maybe instead of me showing the answer right away, you guys can try this one. This is a easier version of number one. So this is easier than number one. And we already did number one together. This is lesson 3.2. Okay, I'm gonna read the question and I want you to think about this before I show you the answer. Determine the end behavior of the graph of this function. The function is 15x to the fifth plus 8x to the fourth minus 3x cubed plus 7x minus 3. Once you think about this, I need a volunteer who shares opinion with me. China.
So we look at the leading degree.
Mhm.
Five,
Good job. Degree is 5. Very good.
and it's odd.
Good job. And we really take care that it's an odd. We don't care what number it is, but we think that it's an odd number. Okay.
Then we look at the leading coefficient,
Good job. Now we look at the leading coefficient, which is
positive.
very good job. It's a 15. It's 15. But we don't care whether it's 15, 25, 30. We really just care that it's a positive number. Good job. Okay.
So it is going to be going down to the left and down to the right.
Now, for odd and positive, the answer is it's going to be down on the left, up on the right. So it's going to be down on the left, up on the right. So you have to memorize these before the test. I don't want you to miss these questions. There's no solving involved. It's just a fact check, right? You can just memorize these 4 cases and then you can get the answer for these questions. Okay. Any questions about number 7? Are we good? Yes? Okay. Number 8. Inequality problem. This was the last lesson I believe we learned in this chapter. It says, solve the inequality, write the solution set in interval notation. And the problem is x plus 5 divided by x minus 3 is greater than or equal to 0. So we're going to solve this inequality. We're going to write the answer in interval notation. Does anybody remember how we handled them?
We say x plus 5 equals 0.
Yes. We
And
said, yes,
Then we say x minus 3 equals 0.
yes. And then we set each one to a 0 to figure out what?
We get -5 and positive 3.
Good job. So the important numbers are -5 makes the top to be a 0 and positive 3 makes the bottom to be a 0. This is a good start. All right. What do we do after this? Okay. First of all, in any circumstances for a rational function, am I ever allowed to use a 3 in my answer? Because 3 makes your denominator to be a 0, we just put an x for 3, right? No matter what, we're not allowed to use a 3. So on the answer, we have to make sure that 3 uses a parenthesis, not a bracket, right? Okay. What about -5? Is it okay to use the -5 in this problem? We want this to be a 0 or greater than a 0. If -5 makes me a 0, am I allowed to use -5? Yes, right? So this will have to use a -5, has to use a bracket instead of a parenthesis because we are allowed to use -5. Okay. Now we have to decide positive and negative regions. Let's test a number less than -5. So what do we want to test? -6. So if you plug in a -6, -6 plus 5 is a negative number, right? -6 minus 3 is another negative number. What's negative divided by negative? Positive. That means whenever I pick a number on the left of -5, it gives me a positive answer. Okay. Now we're going to test the middle region. What number is smart to plug in from the middle region? 0. Let's test the 0. So 0 plus 5 is a positive number. 0 minus 3 is a negative number. If you divide positive by negative, what do you get? Negative. So whenever you're using a number from the middle section, you're getting a negative answer. Finally, we have to test the last region. So what number is smart to plug in? 4. 4 plus 5 is positive. 4 minus 3 is positive. Positive divided by positive is positive. So I'm going to get a positive answer here. Okay. This inequality, the original problem, does it want the negative regions or does it want the positive regions? Because it's greater than a 0, right? Greater than or equal to 0 means positive regions. So we are positive here and we are positive here. So we have to put these together as an interval notation. So let's just do a minus. All right. So this one that I circled first, where does it start from? Negative infinity, comma, negative 5. And is negative 5 using a parenthesis or a bracket? Bracket, because negative 5 is good to use. It just makes us a 0. Union, the last part starts from what number? 3, and 3 is a parenthesis because 3 makes us undefined, comma, positive infinity. And this is how we're going to find the answer to number 8 on the test. Okay, any questions, guys?